Hello students, this is part 3 of the chapter Metallurgy. Now we are going to revise about ionic compounds. Do you all remember what are ionic compounds? These are the compounds which are formed from two units. They have two units, that is they have a cation and an anion, and that is why they are called as ionic compounds. Now as we know that the cations and anions are oppositively charged. Okay, one is positive and one is negative. So that is why they have an electrostatic force of attraction between them. And this force of attraction between the cation and the anion is called as the ionic bond. And these force of attraction are in such a manner that the positive and the negative charges, they balance each other. And that is why the ionic compounds are electrically neutral. Neither they are positive, neither they are negative. In fact, they are neutral. Now the ionic compounds, they have a definite shape. Now they have the arrangement of ions, that is the proper arrangement is there, and this is the reason they are crystalline in nature. We all know that crystalline compounds, they have the proper arrangement. In each of the compounds they have different type of arrangement, and so that is why the arrangement of different ions in the different ionic compound is different. So as the arrangement differs, so there are different structures of the crystalline substances. And as it is crystalline structure, so that is why the negative ions arranged around the positive ions, and the positive ions are arranged around the negative ions. So negative and positive both are arranged in between each other. Also, the electrostatic attraction between these oppositively charged atoms these are very strong. So that is why the melting point of the ionic compounds are high, as there is a strong attraction, so they won't break easily. And the also as they have very strong attraction, the electrostatic force, the two molecules which are joined together, they are attracted together with a strong force. So that is why these compounds are hard. Now let us understand few properties of ionic compounds. Now as ionic compounds have a greater attraction of force between the negative and the positively charged ions, so that is why they exist in solid state and they are hard, and this is the reason they form the crystal. Now the ionic compounds are also brittle, and you can easily apply pressure and make them into pieces. The intermolecular bond which is there, that is the attraction which is there in the ionic compounds, they have the large energy, and that is the reason the ionic compounds do not break very easily, and this is the reason they have high melting and boiling points. Now, the ionic compounds are soluble in water, but they are insoluble in other solvents like kerosene and petrol. Now, why they are soluble in water is because the water molecules, it has the molecules which can be separated by the dissociation process, and this process cannot take place in the other solvent. So, this is the reason why the ionic compounds are soluble in water but insoluble in all the other solvents. Now to check whether the melting point of the salts or the ionic compounds are high or not, you can do an experiment. You can take a burner, you can take a spatula, you can take few salts like sodium chloride, barium chloride or potassium chloride, and you can heat those salt in the spatula. When you will heat it, you will find that it is not breaking very easily. Okay, it takes a lot of time to melt, and so from this we can know that the melting point or the boiling point of these salts are very high. Next is whether the ionic compounds can conduct electricity or not. So for this, we can do an experiment. We can take a beaker and we take the solution of any salt like potassium chloride, barium chloride or sodium chloride. We take two graphite rods which are connected through wire to an electric cell, to a lamp, or you can say a bulb, and we have a press key, that is the switch on and switch off key. Now we have taken the solution, the salt solution, in a beaker. Now as you start the electricity, you need to see whether the electricity can be conducted through this or not. Now, if you remember, we have done this experiment in your 9th standard to conduct electricity through salt solution. So can you remember that whether the bulb glows or not? So yes, the bulb glows, it conducts electricity. But how it conducts electricity, that also we have learned. Now one thing you have to remember is that the ionic compounds cannot conduct electricity when they are in solid state. So if you take a compound of sodium chloride and it is not dissolved in water and you try to make the lamp glow, so it won't glow because in the solid state these do not conduct electricity. But the electricity can be conducted when the ionic compounds are in the fused state or in the molten state. So that is the reason when it is in aqueous solution, so the ionic compounds conduct electricity because they contain the dissociation ion in it. And on passing the current through this solution, the ions move towards the oppositively charged electrodes. And we know that when the ion starts to move through oppositively charged electrodes, so they start to conduct electricity. And this is the reason that electricity can be conducted in the fused or the dissolved state of the ionic compounds. And so as the electricity only be conducted in the fused state or the dissolved state, so that is why the ionic compounds are called as electrolytes, because they cannot conduct the electricity in the solid state. Now here are a few examples of the melting and boiling points of some ionic compounds. So if you see H2O, this is a non-ionic compound, melting point is 0 and the boiling point is 100. But ZnCl2, that is zinc chloride, is an ionic compound. So you see the melting point is 290 degrees Celsius and the boiling point is 732 degrees Celsius. Same is for MgCl2, that is magnesium chloride. If it is an ionic compound, the melting point is 714 degrees Celsius and 1412 degrees Celsius. So you can see the melting points of ionic compounds are very high, and same as the boiling point of the ionic compounds are also very high. Let us now come to metallurgy. Now all that we have learned earlier, so those were the basic terms which will be used in the metallurgy chapter. Now what is metallurgy? Metallurgy is the science and technology which is studying about the extraction of metals from ores, and their purification for the use is called as the metallurgy. So as we know that we extract the metals from ores and we need to purify it. So all those methods, how many types of methods are used, how that purification method is done, so everything is studied under metallurgy. The metals which occurs in the nature exist in two states, the free state and the combined state. Now the free states are found, for example, the silver, gold, platinum, these are generally present in the free state. And these are usually the unreactive metals that are not affected by air, water or other natural factors. But the metals which exist in the combined state can be affected by air, water and other natural factors. So they exist with their salts like oxides, carbonates, sulfides and nitrides. So the compounds of metals that occur in the nature along with the impurities, those are called as the minerals. And the minerals from which you can separate the metals, so these are economically called as the ores. Now the ores contain many types of impurities such as soil, sand, there can be rocky substances and the metal compound is also there. So along with metal compound there are many other impurities which are present, and these impurities as gangue. Now the process of the extraction of metals from their ores is the main thing that we are going to study in this metallurgy. Now the basic principles for metallurgy is when you separate the pure metal from its ore. So there are different methods from which the metals can be separated. Now the concentration of the ores is the first method. Now this is the process of separating the impurities from the ore, and this is called as the concentration of the ores, as we are separating the impurities. And various ways are used for this purpose. Not only just one method is there, there are many methods in which you can separate the impurities, which we call it as gangue. So this is done in this concentration of ores. Now this method, it depends upon the reactivity of the metal, the properties of the metal, and the ore, that is the impurities which is present in the ore. All these factors are considered, and also what type of pollution can be created, what environmental pollution can be created, all these are considered. The first in the concentration of ore is the separation, which is based on gravitation. So here the heavy particles of the ores can be separated from the light particle, that is the impurities, by the gravitational method, and the process can be carried out through again different methods. So here first we have the concentration of ore. Under concentration of ore, the first is separation based on gravitation. That is, whatever these methods are used, in this gravitation is the main thing that we use here.